Welcome to the talk, Is a Modular Monolith the Right Fit for Your Appian Architecture? First of all, I want to thank you all for choosing a presentation that didn't have AI in the title. Yeah. I think, there's not many, and so I'm pretty happy that you all showed up. So just a bit about me before we begin. My name is Matt Drouin. I'm from Montreal, Canada. I'm the owner and operator of Division 61. We're a small Appian agency based out of Montreal. I have 20 years of experience as a solution architect and developer on various transformation projects, financial and public service sectors. I've been working with Appian for the better part of the last 10 years. I'm a certified lead developer. I'm pretty active on Appian community, and just recently launched a site called appiandevs.io with all things Appian, planning to put a bunch of stuff on there. So let's start. The agenda is pretty straightforward. First, we're going to delve into the history of web application architecture to kind of understand why modular monoliths came to be, when and why to use a modular monolith, the challenges and pitfalls, and then the best practices to address to mitigate the possible issues that can follow. So understanding modular monoliths. So give you a bit of context, this is not a new pattern. It's been in existence it's been popularized maybe 5 or 6 years ago, but you even had modular monoliths way back, even 20 years ago. Several ERPs followed that model back in the day. And yeah, we're going to go through down memory lane, go through the history of web application architecture. I felt it was really important to kind of understand why modular monoliths can make sense for you. So if we go back to the year 2000, when I started programming, a while ago, that's why I have to squint to see that screen. There was a web framework called Struts that got introduced in the year 2000, and it basically was based off the model view controller pattern. And essentially, model view controller is pretty simple. It's what you know in Appian. So let's say model would be your record types or your CDTs. The views would be the SAIL interfaces. And the controller you could think of as the processes. So it was pretty simple back then. Pretty much everybody, people were building applications the same way we're building Appian applications today. Everybody was a full stack framework. It was just basically you were coding in Java and you had a bit of HTML, and that was it. Then fast forward a couple of years, there was the release of jQuery, or at least the most popular Ajax framework at that time. And essentially what that started doing is people started sprinkling JavaScript on their pages, right? So you'd have little widgets on your page that would refresh, with new data, but you wouldn't have to reload the whole page to see that data. And so that was the start of the new paradigm, and it was the prelude to single-page application frameworks that we saw, we're going to see a couple of years later. So 2010, we have the release of Angular, which was the first popular single-page application framework. We had React that came a couple of years after. And essentially, that came about for two reasons, essentially. The first reason was because, we started with Ajax. They started doing more and more JavaScript. And also, the advent of mobile, right? So at some point, what happened is, you had, iOS, Android, and then you had your web app, and it was kind of like a separate thing. So what they decided to do is say, well, we'll have, a JavaScript app, we'll have an Android and iOS app, all calling APIs in the backend. So that's what's, started that trend. And then what happened with single-page application frameworks is that you started seeing front-end and back-end developers, right? You had a front-end team, had a back-end team, and it started being split, right? So at that point, so far, so good. It's not too complicated. We're still in a monolith-type scenario. And then 2014, what happened is we started using microservices. That pattern got really popular, especially in large organizations, because, they had to build a lot of stuff, for one. They had large teams. They had a lot of people. And so microservices started being popular in 2014. And the whole concept behind microservices is that you would, instead of having one big back-end API, you would split it up into a lot of small APIs that your apps would consume. So the reason why they went with microservices is because there were problems with monoliths at scale, right? So obviously, if you're just building a small app, there's no issue with a monolith. It's actually a good pattern to follow. But when you're building a large application, you have a large team, you have to build a lot of functionality, monoliths can become an issue. First of all, for example, it can slow down development deployment. If you have a small change, you'd have to redeploy the application. I know in Appian you can probably build a package, but let's say you're building a pipeline, you'd have to retest the whole thing, redeploy, and then go ahead with that. So microservices, what it allowed is isolating the change. So let's say you had a problem with your invoicing API, you could simply do a small change there, unit test it, deploy it, and then you're done. The second problem with monoliths was engineering complexity that came with large teams, right? So if you're working on the same code base, you eventually have people stepping on each other's toes, you have merge conflicts, you have a bunch of other issues. Microservices solve that problem by separating it out, right? You have one team doing maybe an invoice API, you have another team doing another type of API. You might have 20 or 30 microservices, and you have different teams maintaining those microservices. They even had different tech stacks, different infrastructure sometimes. So it was a way to render your team more agile and be able to deliver a lot of stuff at once. And the last thing is sometimes monoliths would lack fault isolation and resilience. In a monolith, sometimes a single bug can crash the whole app. You'll get a 404, get an error message. In a microservices architecture, you might have, for example, your notification API doesn't work, your widget will not work, the rest of the app will function, hopefully. But yeah, you'll isolate some pieces. The app won't just fall down. You'll have maybe some components that will fail, but the gist of the app will continue working. So that's what they were trying to solve with microservices. So at this point, you're like, Matt, you're telling me that microservices is a solution? Well, microservices have their own issues, right? The first big issue with microservices is the lack of the big picture. You have, 20, 30 microservices. You have different dev teams, pushing stuff into production. It's really hard. Each dev team doesn't really know what the other dev team is doing. And so nobody really has the whole thing in their head. It's a bit like the economy, right? So the economy, everybody kind of knows somewhat how it works, but really, in the end, nobody can really predict how things will pan out. The other thing is operational complexity. So you have many moving parts, many microservices, all operating in unison. And you have one little thing can happen, you'd have cascading effects that you didn't anticipate. And then finally, very hard to troubleshoot. You have to put a lot of tooling to be able to troubleshoot and find the root cause of microservices architecture. So that's where modular monoliths kind of come into play. As I said before, they existed long before, but they're really around 2019 that the model kind of came back to, we went from monolith, microservices, and now we're back to modular monoliths for larger applications. So what is it? So a modular monolith is autonomous modules, right, that are based on a business domain. A business domain, I should repeat that. So what is a business domain? You might not be familiar, but a business domain is basically something like, let's say you're building an HR app, you might have a timesheets domain. You'll base your module on that. You might have another domain for compensation, for recruitment. So you want that module to be autonomous for one, and also based on a particular domain. We'll see why a little later. You also want it to be loosely coupled. There's no point in building your modular monolith if you can't push your modules independently of one of each other, right? If you're just, going to build, modules and everything, you have to push everything at the same time, it doesn't really make any sense. So you want to have that loosely coupled. And the way you do that is to have it communicate via interfaces, APIs. So here's an example of a modular monolith. So this is an HR app. So at the top, you'll see you have the common, sort of like the common module, which will have, you might have model elements like, let's say, the employee record type. You might have tasks, notifications, reference data, a bunch of stuff. And then all the other modules that we have here, like recruitment, timesheet, onboarding, are sub-modules, and they're independent. They have their own data model. They have their own interfaces. It's like a self-contained app, if you will. And then each module will expose, well, each of the low-level modules will expose APIs for their data and also APIs to update the data. So here's how it compares to, you'll have kind of in the middle, you have the modular monolith. On the right, you have the microservices and the monolith on the left. You'll see that, it's a bit of a middle ground. And what you're trying to do, you're trying to get as much the benefits that the microservices get you without as much downside, essentially, right? You want some of the benefits, the speed that comes with the microservices architecture, but you don't want as much of the downside. So you have less components in total, less communication channels especially, so you want to minimize those communication channels to make it more manageable. So when and why to use a modular monolith? That's a really hard question. Really, there is no hard rule when you should consider this type of architecture. My personal rule of thumb, and that's just my personal opinion, an app should be about 3 developers. An Appian app, to me, like a monolith, should be about 3 developers. Once you start getting over that number, it's manageable, but it gets more difficult, okay? The same thing with application size. So for me, a typical Appian application is 1,000, 2,000 objects. Once you get past that size, it can always work, but once you get past that size, it also gets more difficult. Your deployments are going to be longer, unless you're doing packages, but that also has some issues sometimes. But if you're doing a full application deploy and you're syncing record types and you're doing a bunch of stuff, it can take a longer while. So if you're cutting it down into different modules, you have maybe instead of, let's say you have a big application, 10,000 objects, and you're cutting it out into maybe 5 modules, that's 5 times 2,000 objects. That might be a little more manageable from a deployment perspective. So, again, there is no hard rule. I'd say like a team size of maybe over 5, you should start maybe considering it, especially for one application. And then also, the application size, I would say, 1,000. I'd say you have to stay within the 1,000, 2,000. Could go all the way up to 3,000 objects, but that starts, I think you're starting to push it a bit at that point. So the reasons why you'll adopt a modular monolith are sort of like the same reasons people adopted microservices in the first place. You want to scale your team, right? So what happens is people come to you and they want to build like a large app. You have a lot of developers, and they want it done quickly. So you want to scale your team. So what the modular monolith allows you to do is have different teams work on the different modules at the same time. And so accelerating your development. Faster and easier deployments. There is a caveat to that, but for the most part, your modules are smaller. Your testing coverage is smaller as well, right? So if you do a change to one module, your testing coverage is going to be that module. You're not testing the whole application necessarily. You might have to do some regression on the full thing, like you do for any type of let's say a microservice architecture where you have to still test the full application, but still you can unit test a lot of the stuff in that particular module to make sure that it didn't break anything. So less coverage. The deployment is going to be faster too because you have less objects. And then finally, conceptual compression. It's a term that was popularized by David Heinemeier Hansson, which was the founder, or not the founder, but the creator of Ruby on Rails, another web framework. And essentially the concept is that people don't have to have the whole application in their head when they're building, right? So if you have one developer working one module, they don't need to understand the whole thing necessarily to be able to work within their domain. Now, obviously, we'll talk a little later. You'll probably want developers to kind of move between modules to get familiarized with the whole thing, so they get because that's one of the issues, the big picture. But if you have somebody starting out, it might be easier to just kind of concentrate on one particular domain rather than having the whole thing to understand from the get-go. So challenges and pitfalls. What to watch out for. So again, what to watch out for are the same things that we saw with microservices, the big picture. So if you have teams that focus too much on their own modules, they don't really know what the other modules are doing, how they work, you might have two things, right? Inconsistent logic in the app. So let's say your error handling in the APIs might be different from one app to the, or one module to the other. You also have like a different user experience. So if you have users going from one module to the other, you might have discrepancies in the experience. So you have to be careful about that, right? And the larger the application, the bigger the problem will be. So you have to, that's something to watch out for. Team autonomy, that's a classic, right? So what's going to happen at some point is people are going to say, well, you got to build, I don't know, this compensation thing, and well, they'll say, well, I have to wait for the timesheet API. Can't do anything until I get that. So team autonomy is an issue sometimes with this architecture, because you'll just be waiting. You have the impression that you have to wait for other people to be done before you can do your stuff. And that's not necessarily true. We'll see in a while. And then dependencies. If you're not careful with your dependency management, yeah, that is one dangerous part of modular monolith, which you have to control really well. We'll talk about that a little later. But yeah, you can introduce, if you're not careful, you can introduce circular dependencies, which could cause issues. If you have tight coupling, what's going to happen is you're going to have to deploy everything at the same time, which kind of neglects, or not neglects, but negates the benefits that you get from this type of architecture. So you have to really be careful about dependencies and coupling between the modules. So best practices. So how do you address all the things that we talked about? The first thing for keeping sight of the big picture. Last year I did a talk here at Appian World, and I talked about how I wasn't a big believer in shared libraries. What I didn't specify, I think, at the time, was that I'm not a big believer in shared libraries at the platform level. So if you have, like, let's say an Appian instance, you have, 50 apps in your Appian instance, I'm not a big believer in having like one shared library for your whole instance that everybody can use. Because what can clearly happen is you're not privy to how everybody's using your components. And so I said that last year, and I still believe it. But at the in a modular monolith, I do think that you should share libraries, because you're in one particular context. Everybody knows, let's say all these modules are using these components because you want to have that consistency in your UI, right? So that's one thing. And then so the other benefit of having shared libraries and components is consistency in the code, so you're not duplicating code. And the second thing is you have consistency in the UI and the user experience, because you're using components, the same component everywhere. The second item that can help you is clear guidelines for code and design, right? So it's very important to have clear guidelines, how you're going to handle errors, how you're going to design processes. When you're going into process models, web APIs, expression rules, should always be kind of the same pattern everywhere for developers to understand. And that's just common good practice, not necessarily specific to modular monoliths, but just a good practice to follow. Have consistency in the code, even though you have maybe different teams working on two different modules. And same thing with design. So you want to have clear, Appian already has some design guidance in the documentation. I think you can come up with your own design system, if you will, maybe a light version. I don't like things to be too prescriptive, but you have a design system kind of just guiding people on how to design their interfaces to have that consistent experience. And then finally, rotating team members. That's a pretty obvious one. So you don't want people being, work on the same module for too long. You want to have them rotating every couple of sprints to make sure that they're familiarized with the picture, they're sensibilized to the reality of other developers in the other modules. Maintaining team autonomy. So that's a big one. The first technique you can use to maintain team autonomy, so the classic problem of, well, I got to wait for that before I can do that, is mocking, right? So what mocking is basically just establishing a contract. so you can, I don't want to build something in compensation, I need something in timesheets, fine. I go talk to the timesheets developer, we just agree on a contract. Might not be all connected, but it's just a mock API that I can connect to, or I can even generate myself as long as we know what the structure is. And then it allows me to develop in my own bubble without having to worry about how the API is going to look later. And then in conjunction, I can use feature toggles. So what's going to do is I'm going to build on that mock. I might push it to production with a feature toggle. I'm not going to enable it because maybe the other person's not done, right? It's not fully functional, it's just a mock. So once the other person, though, is done, once they push the versioning API that works, what you can do is then turn on the toggle, and then you're good to go. And then finally, versioning can help you manage dependencies. So let's say you want to change the structure of the data in your API and whatnot. You don't want to change that live because what's going to do, it's going to break whoever's using it. What you're going to do is version that API. And then maybe change the structure, create a version 2, and then all your different modules can adapt to that new version as they see fit, whenever they're done. And then once everybody's on the new version 2, you can deprecate version 1. Very similar to how Appian deprecates their expression rules in their code. Monitoring dependencies. So this one is a little more tricky. So you want to have clear communication channels. So with microservices, the same thing can happen is, at some point, you lose track of all the different lines of communications between the different modules or APIs. You have to be really mindful before you introduce a new line of communication that it's vetted by, some governance structure that you have within your team, right? So you have to make sure that, if you're introducing a new line that's not currently in existence, as well as, they need to be properly documented, obviously, then, it goes through maybe just a review, make sure, okay, we can have that module talk to that module. You want to be really clear about the channels just to make sure that there are no circular dependencies. So for example, to be a little more concrete, timesheet module talks to compensation, but compensation also calls timesheets. That's no good, right? You want to make sure that there are no circular dependencies when you're calling your APIs. The other thing is deploying frequently, and that mostly applies to the common piece that we talked about earlier, because essentially that's really the only place where you have hard dependencies. The other ones will have maybe API calls to get information and update information, but for the commons module will be where you're going to be getting components, maybe common rules. So those are hard dependencies with your common module. What you want to do is you want to deploy that module pretty frequently because you have other modules that are using it. And if you're too slow to push those code updates out, what's going to happen is you're going to go deploy your timesheet module, and I got 3 dependencies on components that aren't deployed yet, right? So you have to have that regular deployment frequency in the commons module to make sure that you don't have that issue. And then finally, you can check missing precedents to make sure that you're aware of any dependencies that are introduced. Typically, this shouldn't happen, but you're never too careful. I mean, developers sometimes they go in the app, they see a rule they want to use, and checking missing precedents is a very useful tool for checking any dependencies that you weren't expecting. So constantly review that to make sure that nothing new has been introduced. I think I went pretty quickly. So in the end, is a modular monolith the right fit for your Appian architecture? Well, really, it depends. Most likely, no. But in some cases, yeah, it can be a powerful tool. If you have a large application, a large team, it can make sense depending on the context. But like I said, a lot of if you're just building a small app with 2 or 3 developers, obviously it doesn't apply, right? So Appian has additional guidance in Appian Max, managing concurrent delivery teams. They have an actual article on that in Appian Max that you can scan here in the QR code. They also have a shared object management overview, which is a cool article as well. And Appian Max, just in general, I find is a super like a great resource. I encourage you to read up on that. I'm always in that documentation to check the cool stuff that's there. And then, yeah, well, that's it. Thank you for listening to my presentation. I hope you found it useful. You can find my contact information much more on appiandevs.io. I'm happy to connect after if anyone has any questions, even now or at the party later on. And hope you enjoy the rest of the conference.